reflections arising from the focal zone creates images that are more accurate than those from other depths. Of course it is, guys. Of course it is, because that's why our beam is narrow as that. We're going to get great lateral resolution in this area. Okay, so of course it's going to provide us with more accurate imaging. Again, like the picture I drew up here, if the two structures are wider than the shape of the beam, then that beam is going to be able to identify those structures, right? If they're farther apart than the shape of the beam. But if those two structures fall outside of that beam, then it's going to represent two different things. Okay? So half of the focal zone is located in the near field, the other half is located in the far field. Okay? So if our focus is, let's say it's, 10 centimeters deep. Okay? Our focus is from the transducer to the focus, that's 10 centimeters. Okay? Our focus is 10 centimeters deep. That means our focal zone, some of it's going to be, let's say, where the beam is relatively narrow. Like if I ask you, I got a question coming up. I'm gonna table it because I do have a question, a little quiz coming up in a minute. Okay. So basically, it's the region on either side of the focal point where the beam is relatively narrow, resulting in superior image detail or superior lateral resolution. That's why our beam is narrow.
So it's third.
Huh?
It's third 1/3.
The third?
Yeah.
Why is
For
that?
all the distance, near zone plus far zone, multiple 3, so focal zone 1/3. The third.
I wouldn't say that. I wouldn't say that.
You don't say that, but I say that. Is that right or not?
I don't like that description. I don't like that description. 1/3. That's not necessarily true, because the depth of the focus could change. So that wouldn't always be true every time, right? Because if I change the frequency, if I change the diameter, that's going to change the depth of my focal zone. So that wouldn't be true every time. Just eyeballing this image, you could possibly say that just on this image right here, eyeballing that, but that's not true every time. That's not true every time, because we have some determining factors that can change the focal depth. Okay. All right. So our focal zone, half of it's in the near field, half of it's in the far field. All right. Ooh. And just a little diagram I got for you guys, so you can just see another image of it, of how it looks. Okay. So our focal length right here, from our PZT element to the focus, also known as our near zone length. All right. We have our focal region right here. We have our focal zone, the length of the focal region. Remember, once it's two near zone lengths away, the beam is going to diverge even more. It's going to be bigger than the PZT element itself. Okay. We have our far zone length, guys, also known as our Fraunhofer zone. Okay. That's the region of the beam that increases diameter with distance, okay, from the focus. All right. Then we have our we don't have it here, but we have our near zone, which would be from the transducer element to the focus. All right. And like I said, just another image you guys can look at. I just got it for illustration purpose. All right. So let's go back through some facts again about the location and the beam diameter. All right. So at the transducer, guys, the beam diameter is equal to the transducer diameter. Okay. It's not going to be bigger than that. It's not going to be smaller than that. Okay. That means whatever the size of our PZT element, whatever the size of the face of the transducer, this is my element right here. That means my beam is not going to come out like this. It's not going to come out like this. It's going to be the same size of the element itself. Okay? It's not going to be smaller or greater than the size of the PZT element. All right? Okay. At the focus, the beam diameter is half the transducer diameter. See it right here, guys. See the shape of this is how the beam looks straight on. Okay. So at the focus, our beam is half the diameter divided by 2, that it is coming out of the transducer. Okay. At two near zone lengths, one near zone length, another near zone length. Okay. the beam diameter is back equal to the transducer diameter. Okay, which is what I label right here. This dotted line represents the second near zone length. Okay, two near zone lengths from the PZT element.
The second near zone is far zone, right?
Yeah, if you two near zone length, the second near zone is actually located in the far zone. Okay, because the near zone length is from the transducer to the focus. Okay, it's the distance from the transducer to the focus. All right. Then anything deeper than two near zone lengths, anything deeper than this area right here, such as right here, the beam diameter is wider than the transducer diameter. Horrible lateral resolution at this point. Horrible lateral resolution at this point. All right. So
Is that still considered far zone?
definitely, that's still considered. As the beam propagates, all of that past the focus, all that's considered the far zone. Everything past the focus is considered the far zone. Okay? No matter how far it travels. You know, because the beam can get huge. It can be way bigger than the transducer diameter. Okay? So again, at the transducer, guys, whatever the size of the PZT element, the transducer face itself, that's going to be the diameter of the beam as well. Okay? At the focus, it's going to be half of that size. The beam is going to be half the size that it is coming out of the transducer. Okay? At two near zone lengths, the beam is going to be back equal to the transducer diameter. Okay? It's going to be in a perfect hourglass shape. Perfect hourglass shape coming out. Anything deeper than two near zone lengths, the beam is going to be wider than the transducer diameter. All right. Again, another illustration right here, guys. Coming out of the transducer, beam diameter equals the transducer diameter. Okay. At the focus, the beam diameter is half of the transducer diameter. Okay. Distance divided by 2. Diameter divided by 2. Okay. At two near zone lengths, see right here, guys, this is our perfect two near zone lengths. Okay. The beam is back equal to the transducer diameter. All right. Any questions on this before we move on, guys? Questions? Any questions? Go ahead.
This one is only for the continuous wave.
That's what we're talking about. Everything we've been talking about so far has been continuous wave, just so we can understand the concept. But it's the same thing applies with pulse waves as well.
Really?
Okay. Questions? Okay. Jerry? Win? Go. All right. So, answer the little question like we did in the book, guys. I put review questions on the PowerPoint itself. All right. So, we can answer these questions right here based on this information given. All right. So, the diameter of the PZT
12.
is going to be 12 millimeters. See, that's represented right here. This is our diameter of the PZT right here, guys. Our near zone length, our focal depth, or focal length, which is what, Samin?
Focal near zone length.
What is that describing?
Oh, the distance from the transducer to the focus.
Distance from the transducer to the focus, okay? So that distance, guys, is going to be 8 centimeters, okay? And our focal zone is going to be 4 centimeters long, okay? So our focal zone, remember, half of it's in the near zone, half of it's in the far zone. Pat, how much of my focal zone is in the far zone?
2 centimeters.
I'm sorry. I don't know, was it 8?
Hmm?
No,
I'm just asking you a question. How much of that focal zone is in the far zone?
I have a far zone.
4.
Half of it's in the far zone. So that means 2 centimeters is going to be in the near zone, 2 centimeters is going to be in the far zone. Okay? Our focal zone. Okay? Right? We good there, guys?
Yep.
We good there? All right. So
What's the 12 millimeter?
that's describing the diameter of the PZT.
In centimeters? Oh.
The diameter of the PZT
Yeah.
in millimeters, right here. Okay? It's an illustration, so of course it's not going to be accurate numbers. All right? All right. So question number 1, guys. The diameter or width of the beam as it exits the transducer is 12 millimeters, right, guys? Because it's gonna equal the transducer diameter. Okay. The the beam diameter is going to equal the transducer diameter coming out of the transducer. Okay? So the diameter of the width of the beam as it exits the transducer is also going to be 12 millimeters. This point right here, guys, when the beam first starts, is 12 millimeters. Okay? Question number 2. What is the diameter of the beam at 8 centimeters? What do we know? What do we know about the focus?
Halfway.
We know that it's going to be half the beam diameter, right?
6.
So what is our beam diameter at 8 diameter of beam at 8 centimeters?
6 millimeters.
We don't have a consensus?
6 millimeters.
Guys, it's gonna be 6 millimeters, guys. 6 millimeters. Because it's gonna be half the transducer diameter. Okay? It's gonna be half the transducer diameter. Okay? Make sure you use the correct units. Make sure you use the correct units. So the diameter of the beam at 8 centimeters at the focus is gonna be half of the transducer diameter. Transducer diameter is 12 millimeters. Half of that is 6 millimeters. That's what our diameter of the beam is going to be at 8 centimeters. Okay? What is the diameter of the beam at 16 centimeters?
12.
6. 12.
Okay.
12.
What is 16 centimeters equal to?
8 plus 8, so
2 near zone lengths.
Near
2 near zone lengths. Okay? So it's 8 centimeters from our transducer to our focus. Okay? So another 8 centimeters will be 2 near zone lengths, right? So that's going to be 16 centimeters. And our beam is going to be back the size of that it is coming out of the transducer, which is going to be 12 millimeters. Okay? All right? Last question, guys. What is the depth that marks the beginning of the focal zone? Remember, half of our focal zone lies in the near zone or the Fresnel zone. The other half lies in the far or the Fraunhofer zone. Okay? So it's asking you, what depth marks the beginning of the focal zone?
6 centimeters.
I like that, dude. I like that.
Yeah.
I like that. Can I? What? I heard 4 centimeters. 4 centimeters. Hands. 4 centimeters. Sophie. 4 centimeters. Okay. I'll give you guys a second to think about it. You guys a second to think about it. 4 centimeters. 4. 5 centimeters. 6 centimeters. 6 centimeters. 7 centimeters. 8 centimeters.
I think 6.
Okay. Undecided? Undecided, okay. So the depth that marks the beginning of the focal zone, this is our focal zone right here, right?
Yeah.
Our focal zone right here is 4 centimeters long. So this right here, this line right here, marks the beginning of our focal zone, okay? We know that our near zone length is 8 centimeters long, okay? Our half of our focal zone is in the near field, the other half is in the far field. So we're going to take our 8 centimeters from the focus minus half of the focal zone, which is 2, is going to equal 6 centimeters, guys. 6 centimeters. That marks the beginning of our focal zone.
So basically we come to from the starting
From the
here,
focus.
from the focus to this part.
Absolutely, because I'm asking you what marks the beginning of the focal zone. Okay? What depth marks the end of the focal zone? Pat? 2? Think about it. Think about it. What depth marks the end of the focal zone?
End of the focus zone.
No, you
10.
add, yeah, 10.
10 centimeters,
Oh, aim.
right?
And how
Our
it
focal
ends.
zone ends right there, right?
So you add 2.
From the transducer to the focus is 8 centimeters. Okay? The end of our focal zone, which is half of our focal zone, is going to be adding 2 centimeters to the focus.
10.
That's going to mark the end of our focal zone right there at approximately 10 centimeters. Okay? We're good there?
Yep.
Okay, I got a question.
Yes, ma'am.
So for number 2, you said that the diameter of the beam at 8 centimeters, right? But you're specifically asking about the focus, right?
I'm asking you I'm basically asking you what is the diameter beam at the focus?
Okay, so why wouldn't you take half of the 12 instead of the 8 centimeters?
That's what we did.
I thought we.
You asked me about number 2, right?
Yeah, but it says the diameter of the beam at 8 centimeters, so you're not
That-
even technically considering the 8 centimeters, right? It's
Yes,
just,
I have to consider 8 centimeters. I mean, you don't. I'm sorry. You don't have to consider that. Like, I could have asked that question. Just what is the diameter of the beam at the focus? You have to.